Welcome, I'm Jeffrey Snover. I'm a distinguished engineer. I'm the lead architect for Windows Server and System Center Data Center products. And today I'm joined by...
I'm Dan Harmon. I'm a principal program manager on the PowerShell team.
And we're going to talk to you. Yeah, what a fan. I didn't get an applause. You are very popular. I'm jealous. Okay, so we're going to talk to you about remotely managing Nano Server. By the way, how many people have seen my Nano Server talk? Okay, most everybody, not everybody, but most everybody. Okay, well, let's be clear. So this is going to be a level 300 talk. We're going to have lots and lots of details. There's a good chance we'll start a fire here. There's so many components. There's lots of moving parts. Guaranteed something's going to go wrong sometime, so just smile when it happens. We're focusing on IT pros and scripters. The goals for this, we want you to understand the motivations behind Nano Server. We want you to understand how it's going to impact remote management. In the past, we've been working on remote management for a long time. With Nano Server, there is no local logon, so everything has to be done remoting. The great thing about that is that it forces us to really complete the task, make sure that we have no gaps in our coverage. We'll show you how the remote administration features work, both automation and GUIs, and talk about the general improvements in management. You'll see a lot of what I talk about is how the work we do for the cloud benefits greatly the work we do for the people who aren't going to go to the cloud, who are going to stay on the enterprise or stay in that mindset. Although we think everybody's eventually going to move to the cloud, if you're not there this year or next year or the year after that, don't worry, the stuff we're doing still benefits you greatly. So let's talk about what we hear from our customers. Number one, reboots impact my business. Reboots, reboots, reboots. Good Lord, why do I have to reboot a server for a component I don't even use? It just seems unfair. Next, when I have a reboot, I need that machine back in service as quickly as possible. Next. The server images are very large. They're too large. So number one is it takes a long time to install and configure these things. Transferring them around the network consumes a lot of network bandwidth that I'd rather be using to serve my customers, and it requires too much disk space. There's a reason why all the disk dedupe demos show VHD libraries, because they get such great compression, because they're so voluminous. And then also that the infrastructure requires too many resources, that if the operating system consumed fewer resources, there would be more resources to the application, and that if the VMs consumed fewer resources, I could get more of them on a piece of hardware and therefore get better business utilization out of every dollar I spent on hardware. Lastly, of course, last year was the year where security truly exploded, and it was just a mess. And we have found that some customers have this idea of a gold image where they install everything on a gold image, anything anyone could possibly want, and then display that everywhere. That is a security nightmare. If you're doing that, please stop. You are asking for a punch in the face. You will get punched in the face. Seriously, not me. The bad guys will punch you in the face if you're doing this. Stop it. You want to only, that approach really is a bankrupt approach. What ultimately we're hearing on all these things is that customers want the components they need to succeed and then nothing else, right? Everything else that's installed on that system that you're not using is a security risk. It consumes resources, and it requires patching that then precipitates reboots. So we want a world where if I need it, that's great. Look, if you need 5 gigabytes worth of stuff, yay, that's great. You're obviously going to have more patches than if you need 500 megabytes. But if you're using it, you're getting value out of it, and that's a good deal. But if you only need 500 megabytes worth of stuff, having 6 gigabytes worth of components that you have to patch is just not where we want to be. So with Windows Server, we really had this journey where we start off at the early days where we walk up to a machine and did all the local GUIs. The joke was you took a desktop and you went to the top and you pushed it, knocked it on its side and called it a server. And that was great in the days when you walked up to a single machine and there was really no distinction between a client and server. In fact, Mark Rasinovich was the guy who identified the fact that the only difference between a client and a server was a registry key. And if you changed it, you got a server, even though you paid for a client. And then Microsoft changed the location. He found it again, published that. That went back and forth a few times before Microsoft finally sent them a mail saying, we give up, please stop pointing this out. Now, the problem with that was, as I pointed out in the earlier sessions, local GUIs on servers are bad. They're really bad. They're like heroin, right? That first shot feels so good, and then you lead a life of despair, desperation, and ultimate death. Okay? Seriously, that's what local GUIs are. That first shot. I mean, isn't it wonderful? You walk up and, oh, it's so friendly, it's so nice. And as long as your world stays there, right, that one machine, everything's fine. But when we move beyond a data center being a single machine and had multiple machines, that local GUI was a real problem. And in the cloud, it's a disaster. It's death. And the reason for that is, for whatever reason, it's as though it were a law of physics. Engineers, developers, once you have a local GUI, they put business logic in the GUI and call private APIs. And what this means is they don't do the hard work. Look, it's hard work, right, to do a good management interface. But if you don't have a good management interface, you can't do remote management. If you can't do remote management, you can't do bulk management. And if you can't do bulk management, you can't do automation. Again, when it's this machine, this one little machine that you hug, you don't need bulk automation. You don't need automation. You don't need bulk administration. But with a data center of a large number of servers and the cloud, these are critical success factors. That's why I'm telling you these local admin GUIs are death. If you have somebody who's trying to sell you what they call a server product, and they say, yes, you need the GUI for that, say, knock, knock. They're not up to speed. They're not helping you. Anyway, so in 2016, what's that? All your vendors, give them a whack on the face. Don't quote me on that. Okay. So in 2008, we started being clearer about that. We had server core and full server. Server core was a headless option, although you could still RDP into it. And we weren't very crisp about the scenarios. We were going after sort of everything. And we had moderate success with that. The people who were successful really liked it. But we didn't have the full and complete user experience. We didn't have the full and complete set of roles. That really changed in 2012, where we had PowerShell on there. We had more roles, basically all the roles except like fax server and such. We had SQL, more and more of the products running on server core. Additionally, you could start off with server core and move up, or start at the high end and move down. So that worked out pretty well. And then we moved to the cloud, okay? So as we move to the cloud, the two scenarios to get in focus are, first, Azure. All right? Now, Azure does not have live migration. Azure does not have live migration. So what's that mean? That means every time I patch an Azure host, every single customer VM gets shut down and restarted. Guess what? Customers don't like that. And two, imagine the resource consumption of the IOs required to restart every single VM. Right? So huge business impact every time Azure needs to restart, repatch the host. We have a strong commercial interest in not patching the host. We have a strong commercial interest in making sure the host is absolutely secure. So how do you get those two things, resolve those two things? And the answer is reduce the patch service. Next is Azure was going up towards 1 million servers. And very successful in terms of the customer base. Moving all those very large VMs around consumes a ton of network bandwidth. And obviously, with that number of servers, any incremental resource consumption translates into very large COGS, right? And there's another word for COGS. COGS stands for cost of goods sold. A lot of people yawn when you hear COGS. There's another word for COGS that kind of perks people's ears, and that's called profits. Okay? So if your costs go down, your profits go up. So obviously, we do this for profits. So if we can reduce the resource consumed, we can increase our profits. So the point is that we have a commercial interest in reducing the resource consumption. Next, from Windows Server standpoint, we have Cloud Platform Solution. Cloud Platform Solution is our cloud-in-a-box solution. It's 1 to 4 racks of machines. You go to a website, say, I want a cloud. 1 rack, 2 rack, 3 racks, 4 racks. Get a cloud. And that comes pre-configured. There's a very large number of systems in there. The setup of that took really a long time. My joke is that before CPS, we did not have long setup times. You had long setup times, but we didn't, because I'd just go and I'd install a server on this machine, grab a cup of coffee, talk to some people, come back and be done. And with CPS was the first time it was like, wait, so now I've got to deploy this on a very large number of systems. I got to set up a very complicated management head with a large number of highly available instances of server system center running. And boy, did that take a long time. And boy, did it consume a lot of resources moving all those bytes around. So again, it's sort of, you didn't get that issue in focus when you were just dealing with singletons or onesie twosies. But as soon as you had a very large system, that problem became very clear. Next, now, CPS does have live migration. CPS has live migration. So what that means is if I patch the host, not an issue, no drama. What we do is we drain the workloads from that. We live migrate that to one machine. We then patch and reboot that server, and then we move the workloads back, and then we do it to the next one, and the next one, and the next one. So we can patch the hosts without service interruption. Good deal? Well, let's do the math. 4-rack CPS system has 8,000 VMs. 8,000 VMs by roughly 2 gigabytes each. That is 16 terabytes of memory that needs to be live migrated every time there's a patch. So whereas there is perhaps not a service interruption, there is most definitely a service impact, because that's 16 terabytes of bandwidth that I might have otherwise been using to satisfy customer requests. So we have a strong commercial interest in getting that resolved. So ultimately, what we're trying to say here is that we need a server that's optimized for the cloud. Now, this is a literal statement. Literally, I need this, right? I need this for my CPS business. I need this for my Azure business. I need a server optimized for the cloud, and I'm pretty sure you need it as well, okay? And so that's what Nano Server is. So Nano Server is a new installation option for server. Notice it's an installation option. It is not a separate SKU. It is an installation option of the SKUs. It is 64-bit only. There is no WoW 64 or 32-bit compatibility support. And it is headless only. There is no graphic stack. There is no graphic stack. There's no local login. It is completely, wholeheartedly headless, and I love it. This is really a deep refactoring of the server based upon 2 scenarios. First is Cloud OS infrastructure. Cloud OS infrastructure. So think about CPS. CPS, on the physical machines, we only have 2 types of servers. One is clustered hypervisors to run the VMs, and the other is clustered storage. That's what we are doing for Cloud OS infrastructure in this first phase of deployment of Nano Server. The second scenario is born in the cloud applications. So these are applications built with a cloud design center. They're built to run with cloud semantics and a cloud management style, sort of a DevOps-y style of doing things. Now this will also then run in physical virtual machines or in containers. Nano Server and containers, like peanut butter and chocolate. I mean, they both are great individually. You put them together, it's wonderful. Now again, we're going to extend this server core pattern. The server core pattern basically says to start off with, they are separate. You pick one or you pick the other. You pick Nano Server or you pick server core, and you better get it right, because if you got it wrong, you got to restart from scratch. That's not like a desirable thing. That just turns out to be a lot of hard engineering, and we haven't done that work yet. It will be done later. The second is that there are no binaries or metadata in the image. So one of the reasons why these images are so large is, if you've ever noticed, when you go to install, you're on server, and you say, oh, I'd like to have the web server. Notice it never asks you, please insert the media. Do you ever wonder why that was? And the answer is, during the installation, we take all the components and we put them on the disk. And then when you say, show me what I have, we just show you the ones that you've installed, but the others are still there. And then when you say, I'd like to install the web server, we just say, take it from this side of the disk and put it to that side and show it to you. Then it's installed. So anyway, that's not the case with Nano Server. With Nano Server, you install the components as you would an application, which is to say they come with the bits themselves. Stop that, Dan. Okay, it has full driver support. The thing to be clear is it is Win32. It is Windows Server. It is just a subset of Windows Server. It's full API compatible with all the things that Windows Server does for the components it has. And it has the anti-malware agent installed. Now, why is all this interesting? And the answer is this. The answer is this. Okay? We are achieving dramatic results with this. And these are preliminary numbers, but they are compelling preliminary numbers. We have not done a performance pass, so these numbers we expect to get better. Ports open go from 34 in full server down to 12 in Nano Server. Reboots per year, we measured the number of reboots due to patching in 2014. There were 11 for full server. There are 3, so a little bit more than 1/4 the number of reboots. In terms of first boots, seconds to get to first boot goes from 62 down to 12. Critical patches go from 22 down to 2. And the VHD size, just look at this and let it sink in. The VHD size goes from 8.3 down to 410 megabytes. 20 times smaller. It's just crazy. It's wonderful. Anyway, so now we're going to talk to you about managing this. I mentioned to you that it is headless only, and you do remote management. Okay? So a lot of you, I know, have talked with you, and you've talked to me and said, hey, some people in my company, we've been trying to get on headless, and we've been doing server core, and there are people who say, well, I don't like remote GUIs. I don't want to learn PowerShell. And my advice to you is, the next time you have a conversation with that person, I want you to look at them and think of this chart. And ask yourself the question, is the person I'm talking to really worth that much memory? Are they really worth that many 10 times more critical math? Is that person really worth 4 times as many reboots per year? Is that person and their unwillingness to grow in their paid profession as an IT professional, is that alleged professional really worth all that? And the answer may be yes. That would be an interesting conclusion. So now, just to be clear, look, there have been reasons, I understand. There have been reasons why we have had gaps in our coverage, there have been issues, etc., and we take that very seriously. Obviously, those of you that have moved this, you've encountered some of the struggles, we know that, and we're going to make it much easier, and we're investing heavily in that so that everybody can move to this world of all skill levels. So with that, let's talk about Server Manager.
Which number are you on?
I have no idea how you set this up.
Which one is this one? What does that say? 1?
VGA.
VGA 1.
That's... There we go. Come here. I forgot the password. What? Payment. Oh, God.
Caps lock still.
Oh, good Lord. Voila. Okay, so now we have Server Manager.
That was the demo.
Okay, so this is Server Manager, behold, And just as is, we'll come in here, excuse me, show you all the servers. What do we have here? Got Nano, GB. So anyway, this is managing, can't read the things, but a number of Nano servers. So here's my little Hyper-V stack right here. Okay, running Nano servers, and this is attached to them, and you'll see Nano server just works here. Okay, you see the events, you see the services. We don't have the best practice analyzers or the performance stuff running, but here are the roles and features. Okay, so then as I come here, let's see, events. Anyway, all the stuff you expect to work, most of it is going to work by the time we ship. I expect all of it. Here's files and servers. Okay, so here's all the servers. I'll go to shares. Okay, let's get rid of this. What am I looking at? Oh, okay. So I go select this machine. There we go, select this machine. Come to tasks, and I'll say new share. By the way, it's very difficult. It's way over here, or it's over here, so that's why I'm fumbling a bit. But, so now what I've done is we've got Server Manager connected to a bunch of these Nano server machines. Now I'm connected to this one, and I said I'd like to create a new share. So go through the GUI, select the disk, share name, God help me. Voila, that default looks perfect right about now. And what, did you see that? I hope you didn't blink because it just happened. And there we go. There's our server. Okay? Stop sharing, copy share, properties. There you go. Oh, and here you can change it. Anyway, so we have Server Manager, a tool you're used to, now just works against Nano Server. Happy days.
All right. All right. Thanks, Jeffrey. That was a great intro. So I'm going to talk to you a little bit about how so we have this Nano server. How do you remotely manage it? We have a set of investments that we've made. It really breaks down across these 5 buckets. The first is investment in making the GUI tools work remotely. So as Jeffrey showed, Server Manager, that works remotely against Nano Server. And then we're also investing in a set of new web-based tools that will plug into the Azure portal. So that includes replacements for a lot of the things that, a lot of the GUI tools that you use locally, like Task Manager, Registry Editor, Event Viewer, Device and Driver Management, those things. And we're working on plugging those things, the web-based tools, into the Azure portal. The second big bucket is obviously around PowerShell. PowerShell is key to automation, and PowerShell remoting we have working now on Nano Server. So we've ported PowerShell to Core CLR. We have a lot of the pieces running now. We're also working to port a lot of the commandlets for both the core windows like storage and networking, and then also stuff that's part of Windows Server itself. We've also made some new improvements as well, which I'll be demoing to you a little bit later. The third bucket is around VM and container management. So you got the Hyper-V tools that you know and love, Hyper-V Manager, the commandlets, those work. We've also made some improvements in these tools as well. I don't know if you saw any of the Hyper-V sessions earlier this week, but I believe they showed a new feature in the commandlets called PowerShell Direct. And this is working over PSRP directly between the host and the guest VMs. So that's really cool.
Wait, do you have that in focus? So what that means is you can have a VM that has no networking stack, it has no NICs, and then you can do PowerShell remoting into that. How can you do that? Well, there's a channel between the host and the guest. It's over the VM bus. And so then you can run PowerShell in there. You'll see we have PowerShell extensions to do file copies, and so you can copy files, execute commands, including add a NIC, and now set its IP address. So a lot of people have asked, oh, well, with this headless thing, what happens when I have a problem with the networking? Well, if it's a VM, you can just use this host-guest channel to resolve it.
Yep. Yeah, we don't have a demo on that one, but we do have some other cool demos, including one around this new SIM session support. So I'll be showing that. We have SIM session on all the Hyper-V commandlets, which is really cool. In terms of deployment and monitoring, we have support for DISM and VHDs. Also, we have the DSC local config manager. That's the LCM component that applies the configurations. That's working now. I don't believe that's working in the Ignite build bits that you guys get, but that's we have that working internally, so that'll be available in the next drop that we give you guys. And then in terms of partners and frameworks, we have Chef integration, .NET Core and Core CLR, which I'll be talking about, support for a bunch of different languages, and then some additional improvements in PowerShell itself, like classes. We don't have time to demo that, but there'll be a demo of that on the Channel 9, where we have a class keyword, so you can define your own types in PowerShell now. There's also a PowerShell script analyzer, which is used for analyzing a script against best practices, and then the gallery in PowerShell Get. So let me just drill a little bit into the work we've done to get PowerShell running on Nano Server. So this is a little bit different than what you might see on like a full client SKU of Windows. First of all, it's built on what's called .NET Core. And .NET Core is really the next version of the .NET framework. It's lean, it's composable, it's open source, and it's also cross-platform. So that's a really great fit for what we're trying to do with PowerShell and what we're trying to do on Nano Server. So you can just take the pieces that you want, bring them along with you, and have it really composable and small. So the pieces that we need is the core runtime is called Core CLR, and then there's ASP.NET 5. We only need a few pieces of that to do some networking stuff. And then we use the C# Roslyn compiler, which is the new compiler for C#. So then when you look at the disk footprint doing that work, it really comes out to a nice about 55 meg. That's for the Core CLR runtime, all the libraries we need, plus PowerShell, plus the modules. And compare that to like the full .NET framework, which is in the gigabytes range. This is much, much smaller. So it's really great. In terms of what we have working right now, again, this is sort of we haven't released Windows Server yet. We still have a whole nother year that we're going to be working on this stuff. But so it's in process. But at this point, we have the full language ported and ready to go. It was really important for us with the shift to Nano Server that we wanted to maintain compatibility from a language perspective. When you go and write scripts on Nano Server, we wanted those same scripts to be able to run on the full desktop SKU. Now, obviously, the reverse isn't going to be true because there's a much reduced surface area on Nano, but we wanted to have that compatibility from a language perspective. So obviously, we have a subset of the features right now and the commandlets as well, but we'll be filling out the commandlets over time. You'll see more and more stuff start to come in. The other key piece is we've got PowerShell remoting working. Almost all of the remoting stuff is working now. So you can do things like create a new session, you can say invoke command, you can do enter PS session, all that stuff works. I think we don't quite have working some stuff like session configurations aren't quite there yet, and a couple of other minor things. But for the most part, that full stack is there. The other cool thing is that we are backwards compatible all the way down to V2. So we didn't make any breaking changes or anything there, which is really great. And then, as I said, we've invested in a couple new features, file transfer over PowerShell remoting, which is one of my favorite features that we've done over the past year or so. It's really cool. I'll be doing a demo of that. And then remote script authoring and debugging in the ISC, which I'll be showing you. And then we're continuing to work with our partners internally and externally to get more and more commandlets for managing the components that are going to be shipping in Nano. And with that, let me do a demo on what PowerShell on Nano looks like. Flip over to this guy. Let's close that guy. All right. So first the first thing you want to do is you want to make sure that your WSMan trusted host is set up if you haven't done that, especially for workgroup scenarios. So I get a lot of questions about this, so I just want to show you in the WSMan drive. You can just see, trusted host. There we go. I just set it to star because for demo purposes, but you want to input the IP addresses of the machines you're trying to manage if you're in a workgroup environment. And then let's go ahead and...
Don't use star.
Correct. So I'll grab my IP address here. Let me get some credentials. And then I'm just going to go ahead and create a new session. So I have a Nano server VM running right here. As you can see, Hyper-V Manager, PowerShell, and Nano is the guy that I'm connecting to. So there's my session. See, it's open, ready to go. And then invoke command works as expected. So pass it a script block here, grab the PID, get the list of processes. There's our PID, there's our processes. And I can also do an interactive session. So I can use enter PS session. Notice the prompt changed up here. And then, like I said, we have the full language working. Let me just back out here. So here's a simple language expression. Let's do a for each. Thanks. 11 through 13. We've got the, let's do the range or the format operator here. We'll add a binary operator. So it's a pretty short expression, but it shows you we got loops working, we got range operator, we got format operator, we've got binary operators, we got support for hash tables, type conversion, literals, flow control, all that stuff is working.
Whenever you need a board demo, just talk to Dan.
We also have support for .NET method invocation. Notice we got tab completion working, so that's great. So let me show you here. Exist, C, Windows, that should work. Cool. Now again, the set of types you can have available on Nano is way less than what you would expect on like a full client SKU. Just keep that in mind. And we have support for pipeline and output redirection, argument completion, globbing, all that stuff. So for example, get command, I can do star-content. There's my commandlets there. Pipe that to select. Grab the first couple there. Output that to $env temp. Test redirection. There we go. Now I can get content on that guy. env temp. Test re. There we go. Get the content back, so all that's working. We got support for functions, so you can say like function, say hello. Hello. That's all good. And we've also added support, made sure that our CDXML, our SIM-based modules all work. So all that infrastructure is there as well. So if you do a get module dash list, you can see the list of modules that we got here. A lot of these are actually SIM-based. Yep. For example, let's go and import the net TCP IP module. It should come up. See, there we go. And now we can do get command net TCP IP. These are all commands we got there for networking. We've got the net adapter module working. So you can say like get net adapter physical. That should work. Cool. And then, of course, I've been typing import module. You don't have to do that. We have auto loading working. So if you want to go like get disk, this is in the storage module. It's going to go and check the command cache, find out which module it is, load the module, and automatically. So that's working. Get volume. And then we also have support for a new module called for managing devices and drivers. This is called PNP device. And these guys did a really great job. They had their module working before we even had PowerShell fully working on there. It was already in. So hats off to those guys. And this is really cool. It goes and grabs all of the devices on the system, which is really handy. And you can do just grab the first one, let's say, and PNP device property. Now you get all the properties back, and you can see we got stuff about drivers, we got stuff about the hardware. So that's going to be really handy to have that coverage there. We've got support for all the not all the providers, but a lot of providers, and the infrastructure there works. And see, we have those providers and their drives, registry, environment, file system, all that good stuff. You can do a get child item on on the registry, let's say. So you can access the registry. And then in terms of the PowerShell built-in commandlets, we're still filling out the coverage there. But if you take a look at the list of commandlets, let's just measure that. We've got, what did I mess up? Get command.
Not command, just to measure.
Oh, measure. I said measure command.
Yep.
Measure. There we go. So we got 261 there right now, and we're continuing to add. Now that we have the foundation in place, it's much easier for us to just add more and more commandlets over time. Get your C in there. Get your vitamin C, man. Yeah.
All the sim commandlets are functions.
Right. Good point.
So it's much larger.
Yep.
Look at that. Before your very eyes, we've nearly tripled the number of commandlets.
Yeah. So that's working. Get service is working. Let me show you one real quick. So here, can pause and continue. How many of those are there?
Oh.
It's only a couple. Select the first one there. Suspend it. There you go. Suspended that guy. Now let's resume it. Resumed. Okay. So that just gives you a kind of a rundown of all the stuff in core PowerShell that we have working so far. Let's see, switch back. And this chart, I'm not going to go through everything here, but I wanted to give you guys a flavor for kind of what works today and what we're still working on. Kind of gave in the demo, you saw a lot of the stuff that works. In terms of what doesn't work yet, I wanted to call out 3 things specifically. So first of all, add type. The add type commandlet is not going to be supported. There's too many dependencies that it drags in. However, in V5, we have added support for PowerShell classes, as I mentioned. And so if you need to write custom types, you can now do that in PowerShell language itself, which is really cool. The other one I want to call out is the WMI V1 commandlets, like get WMI object. Those are also not going to be supported. However, we do have the sim commandlets module that's already ported, that's working, and so you can, and those commandlets are backwards compatible with WMI v1. So you can just replace your get WMI objects with get sim instance, and you'll be good to go. And then the other one is PowerShell workflow. Workflow depends on Windows Workflow Foundation, which is not part of .NET Core or Core CLR. And so that one's not going to run on Nano. If you need to run workflow, you can continue to run it in a full server SKU as a VM on top of Nano. That will work fine, or in Orchestrator. And then I also wanted to talk to you guys a little bit about what the investments we're making in PowerShell 5.0. Not all of these are working on Nano yet, but to give you an idea of some of the investment areas we're making. A huge area where we're investing in is around scripting, security, and protection. So we're doing a lot of work around transcription, comprehensive transcription, logging. We have a set of cryptographic message commandlets. We have some secure code generation APIs where we're plugging into the anti-malware engine to make sure that the scripts are safe to run.
Yeah, that's a crazy feature. So in Windows 10, we've extended the anti-malware agent so that it can check scripting scripts. So now Windows 10 will check for PowerShell malware or VBScript malware, etc. It's wonderful.
Yeah. We have a demo of that actually. We're not going to be able to show it today, but we'll probably post it on like Channel 9 or something.
Oh,
so
yeah.
You guys will be able to check it out. Utility commandlets, we have support for archive, zip, which is one of my favorite ones. Also, if you haven't seen the convert from string stuff, it's super cool. It's based on some stuff out of Microsoft Research that we took advantage of. We got full symbolic link support now in V5.
Well, let's explain what it is. So convert from string basically does parse by example. So anybody, who's really facile with regular expressions? Now I'm going to put my hand right down. Okay, so some of you. I'm not. I've been using them for 30 years. I still can't get the hang of them. Anyway, well, a lot of times you still have to do parsing, text parsing, whether it's the properties in an event field, whatever. Well, with parse by example, what you're able to do is you're able to take an example output and just go in there and tag it with some, this is a object, this is a property, etc., and use that as a template, and then it will auto generate a parser for you and parse your text based upon the examples you provided. So it's crazy cool sort of AI technology. It synthesizes a text parser for you.
Yeah, that's really cool stuff. New modules, I just showed PMP device, which is one of my favorites. There's some other ones up there. We also have a lot of work in the community and around development. So we have a PowerShell script analyzer, which analyzes your scripts for best practices. That's actually posted now on GitHub. And we're expanding that to be able to take a script that you want to run on Nano and then ask Script Analyzer, hey, will this thing run on Nano, or am I using stuff I can't use? And so that's going to be a really handy tool for your remote management scripts. We have the PowerShell Gallery along with PowerShell Get, OneGet, which is now called Package Management, classes, as I mentioned, and then a whole bunch of stuff around remote management, which I'm going to get
And you skipped right over it. We got huge news here. So I don't know if you've seen this, but basically you can now unit test your PowerShell scripts with a unit test framework called Pester. Now here's the thing about Pester. Pester is an open source community project, and instead of being compatible with Pester, we're using Pester. That is to say, we, for the first time ever, are taking an open source software and shipping it as part of Windows. Is that crazy? But wait, it gets weirder. It gets even better. It turns out that as we looked at Pester, we said, hey, this is fantastic, but it doesn't really meet our full range of needs. We're going to have to extend this. And as we looked at the things that we were going to have to extend, we looked at that and we said, those other guys are going to need this too. Let's see if they want to join with us and jointly adopt this Pester and extend it for the benefit of our mutual companies, for our mutual customers. And so I reached out to VMware and I said, would you like to join Microsoft in taking this open source project and jointly extending it? And that is the case. So now we're working together with VMware to take this open source software, now shipping in Windows, and we're going to communicate it to our joint communities to use this as the way going forward. This is not your dad's Microsoft.
I had to let you take that one. That was too fun. Right, so next one I want to drill into remote script editing and debugging. So we have one of my favorite features that we have, and it's working on Nano, is support for copying files over PowerShell remoting with PS sessions. So now, of course, this isn't going to be like as fast as SMB, so don't go like trying to, blast 100 VHDs across this channel. This is really about, scripts and things like that. But it's going to come in super, super handy when you're trying to remotely manage Nano. We've augmented copy item. We've added a couple new parameters to session and from session. So now you can copy files back and forth. So you don't need to open any other ports as long as you have a remoting session. You're good to go. And I'll be demoing that. Remote file editing in the ISE. So this is being able to basically have a script on your Nano server. If you've got ISE connection to it over remoting, you can just say PS edit and edit it right in the ISE. Interactive script debugging. So this is the command line debugger. We have that working, so you can, if you like the command line debugger, you can use that. Or if you like the graphical debugger in the ISE, you can also use that remotely now. We've also added a few new commandlets around host process connection. So you can get a list of the processes on the remote machine that are hosting PowerShell. Those might be other sessions or something else. And you can connect to those remotely and then debug into those if they're having issues.
Let's show them.
All right, let's show them. So remote debugging. All right. So while Jeffrey was blabbing about Pester and all that cool stuff, I was setting this up a little bit. Got the Nano IP in there and the credentials. So let's go ahead and open a new PS session to our Nano server. Pass it the credentials. There we go. And let's just open an interactive session with that guy. All right, there we are. Now I have a folder in here, a test folder. And, okay, so right now this folder is empty, this test folder is empty. I just want to show you that. So let me just back out here, and we're back to our management client. And if I go into here, I got a script in here. Yeah, okay. Let's go PS edit on this node GWMI script. And let's take a look at what this does. So this is just going to, pretty simple script, just going to run some IP config. It's going to call some get WMI object to get the computer system info, and then it's going to output some really important information. Pretty simple script. So what we want to do is we want to run this on Nano. So we're going to use our new copy item feature to copy it over to our Nano server. First, let me just show you this guy. Copy item, syntax. Here we've got the from session and to session down here. So let's say copy item, to session. We got our session there. Path is, now when you're going to, the path is going to be the source one, right? So that's locally here. That's our demo and our node GWMI script. And then the destination is going to be the one on the remote side. And okay, so we don't have tab completion on the remote working yet, but wouldn't it be cool if that worked? I just think that would be really cool if that worked. All right, so that flashed really quick. And then let's try the other way. Let's go from session, and let's get path. Let's grab the DISM logs from the remote machine. So we're always digging through those, right? Demo. We'll bring it back over to our local demo. Okay, notice how that flashed real quick with some progress. Now let's take a look, and there's our DISM log. Let's just open that real quick.
61K.
There it is.
That's pretty reasonable.
DISM log right there. And now let's take a look to see if our test script made it over. So we're going to do an enter PS session back across, and do a dir on there. And there's our node GWMI script. Now let's go ahead and run our script over PowerShell remoting. Not demo. Let's just invoke it. There it is. All right. Okay, looks like we got a little bit of problem. Our IP config ran okay, but then when we were getting our computer system info, looks like we were calling, we had an error there. So let's go ahead and take a look at that. Now remember, we're in a remoted session here, and I just opened the file remotely over PowerShell remoting in the ISE. So you can see up here it says remote file, so you know. And now I can inspect it real easily. Oh, I can see this is get WMI object. This isn't supported. Let me just change this to get sim instance and save. Works seamlessly, no issue there. Let's see. So now we should be able to just close this guy and run it again. See how we're going. Awesome. Okay, IP config looks good. We're getting our computer system and our important output. No server rocks with PowerShell?
No, that's not correct.
What is that?
That is incorrect.
That's not quite right. I'm pretty sure that's not right. I know that's not right. All right, we got to fix this. So let's edit that thing again, see what's going on here. I've got these two. I'm looking at this. I'm not quite sure what's wrong, but I can see that. Let's go ahead and add a breakpoint here on this line. Something's going on there. And let's go ahead and hit F5 to run our script again. Notice we're debugging now the remote script. On the remote side, we've just entered a remote debugging session. And I can see what's going on here.
Does IntelliSense work?
IntelliSense does work. So let's see.
Why don't you show us?
Hey, it's at 0. What do you want? String. Boom.
No, like.
Oh, yeah, that works. All that stuff works, indeed. I didn't know that worked, but I'm glad it does. Cool. Oh, I can see now that I got this +2. That doesn't need to be there. So let me just stop the debugger. Let me edit that thing out. Let me save it. Back to the remote. I'll remove all my breakpoints. We should be good. Run it again. Ah, there we go. Nano server rocks with PowerShell.
That's
How about
better.
that one? All right, let's switch back.
All right, so let's talk about what does run on Nano Server. Mentioned to you that we're focused in on CloudOS infrastructure and born in the cloud applications. So we've got ASP.NET v5 running, Python, PHP, Node.js, Go, Java, Ruby, more to come in this space. In terms of cloud components, we've got Nginx, we've got Redis, MySQL, .NET Core, OpenSSL, SQLite, management agents, we've got Chef, SCVMM, Ops Manager. We have those. You don't have those. You won't be able to get those for a bit. Ops Insight, VSO Ops Insight, and the desired state configuration agent running on this. So quite a bit. As I say, the bits that you have this week do not have all these available, but we have them running in our labs, and we'll be making them available to you later. I don't know when.
Batteries. I don't know.
Well, if
Try
you
to-
were,
There you go.
where's our keyboard? Hidden?
Yeah,
All
too
right.
much stuff up here.
All right. Oh, I do need the mouse.
Oh, you need to do video,
Yeah.
right? All right. Okay, let's bring this guy out.
Okay, so here, we actually don't have good internet connectivity, and so I did this demo live yesterday, and it failed because I didn't have connectivity, so we're going to show you a...
Tell me when you want to go.
Go.
Ready to go?
This is a video version of the demo.
Hopefully we got audio.
Can we get some audio?
Chef configuration management running on Nano Server. Chef is used here to run a simple web app built with a Django web application framework and using Nginx as a reverse proxy server. Chef provides the recipes for configuring Django, Nginx, and Python, which, as you know, is what Django runs on. We start by using PowerShell remoting to remote into the Nano Server machine. We'll change directory to Chef64 bin and run the Chef client. Let's just go ahead and fast forward this part, and we're almost ready to run our web app. Before we do, I need to copy the IP address and paste it into Internet Explorer and use port 80. This is a simple web app that helps manage polls, so I'm going to create a sample poll. After entering my credentials, I'll choose the commute poll and enter car, just because I love driving. Let's take a quick look at the Django recipe. For that, I'm going to leverage PowerShell ISE's cool new feature of editing remote files. This same Chef recipe can be used on developer systems and within continuous integration workflows to deploy the application to various test and staging environments. That's it. In this short early demo, you saw how Chef, and therefore Ruby, Django, Python, and Nginx all ran on Nano Server. This server may be nano in size, but certainly not in power. Thanks for watching.
All right, so what you saw there, and again, the reason why that failed yesterday was that part of that recipe goes out to the internet to grab the latest versions of those components. So it's actually when you have an internet, it's very, very quick. Or if you have a local repository, it's very, very quick. Anyway, what you saw was Nginx. Nginx is written in C. You saw Django, which was PHP. And you have Chef, written in Ruby, all running on Nano Server.
Woo! All right. All right, next guy. We want to talk about Hyper-V. We got Hyper-V running on Nano, of course. It's one of the key scenarios for compute. And in terms of remote management of Hyper-V, you can continue to use the tools you know and love with Hyper-V Manager and the Hyper-V PowerShell module. And again, those are going to be running on your management client and remotely targeting the Nano server. We also have, as Jeffrey talked about, this really great feature, PowerShell Direct over PSRP. It's really, we took the typically the PowerShell remoting protocol is layered over top of WSMan. But what we did is we wanted those same PSRP semantics, and we layered it over top of this VM bus, this hosted VM local bus that exists in Hyper-V. And so you have this nice consistent experience where you can say enter PS session, and then instead of giving a computer name, you can give it a VM name or a VM GUID, and then you have an interactive remoting session to that VM straight from the host. So this totally bypasses WinRM, it totally bypasses the networking stack, allows you to troubleshoot issues. I kind of think about it as the difference between opening an RDP session, which requires the network, versus if you have Hyper-V Manager running and you just like double click a VM and it opens up in the virtual machine connection, doesn't require any networking at all. That's a similar experience from the command line. And then we've augmented the Hyper-V commandlets to have the SIM session parameter. Right now, the Hyper-V commandlets already had the computer name parameter. When you use that, it goes over DCOM. So the SIM session allows it to work over WMIV2, which means over WSMan and PowerShell remoting. So you can just have the one. If you have a PowerShell remoting connection, then the SIM session parameter will just work. And then you can use all the commandlets in the SIM commandlets module for managing SIM sessions, just like you normally do. And with that, let me show you a demo of remotely managing Hyper-V. This one's number 7. Switch it over. Okay, so what I got up here, I got it set up. I have another machine, another one of these little gigabyte machines. As you can see, that's running my Nano server. And I've got it, there's no video output on this at all. I've just got it networked straight into this demo laptop here. And that's where I'm going to be running everything from. So I've started off, I went ahead and collected the IP address and credentials for the Nano VM. And one commandlet that came in super handy for me setting stuff up is the test WSMan commandlet. I don't know if you guys use this a lot. Anybody use this at all to test stuff? It's kind of like ping for WSMan. It sends an unauthenticated packet, WSMan packet to the machine. So even if the authentication is not working or whatever, as long as PowerShell remoting is working at all, then this thing will work. So it's a really handy commandlet to use, and I've used it a lot getting my demos and stuff set up. So let's go ahead and open a interactive session here. We'll pass in the computer name, the credentials, $cred. So this is going to open an interactive remoting session from this laptop to the headless Nano server there. Now I'm going to show you the modules that we got. This should look familiar from my previous demo. We've got a lot of modules available right now. And let's go ahead and import the SIM commandlets module. So I can use get SIM instance here. And I'm going to verify that I'm working against the gigabyte machine. So do Win32 computer system. You can see here, gigabyte machine, the model, all that stuff. And let's do get sim instance to verify that I am actually running Nano server. I'm going to do Win32 operating system. Format list there. We'll grab the CS name, caption, manufacturer. There we go. So you can see I'm running Nano on here. I'm running the technical preview 2. The code name for Nano used to be Tuva. That's why if you see the caption it says Tuva, that means Nano server. And then let's take a look again at the modules that we have available. We've also got the DISM module here available. So that's going to be real handy for you. So let's go ahead and import the DISM module. And we can use the Get Windows optional feature, past the online switch there. And let's look at the state of what we have installed right now. So we'll look for enabled, format that as a table. So this is going to come back and tell us what stuff I've installed here. So you can see I've got the file and storage stuff installed, the SMB Direct, and also I have Hyper-V running on this Nano server here. All right, so let's back out of that session. And now we're back at the management client, and I wanted to show you something that I have here. I went ahead and on the management client, I went and installed the Hyper-V management tools, so the GUI tools and the module for PowerShell. So we can use the Hyper-V module here on the management client. And on all of the Hyper-V commandlets, we've added the sim session parameters I mentioned. So you take a look at the get VM, for example. Look at the syntax here. You got sim session now in addition to computer name. You want to specify sim session to go over the WSMan instead of DCOM. So let's go ahead and create a new sim session that we can use. Computer name, Nano server, out variable CS. Oh, I used sim instance, sorry. New sim session. There we go, there's our sim instance. And now let's go ahead and get a list of VMs running on this guy. We'll use sim session, $CS. Okay, so that worked. We don't have any VMs yet. So let's go ahead and create a VM. We'll say new VM, sim session, name Nano server VM, we'll call it. We'll give it a VHD path, demo. And again, this is a remote path on the Nano server. Here we go. Should be creating a new VM over PowerShell remoting.
Cool.
And now let's go ahead and start the VM. Sim session, name Nano server VM. Starting it up, get VM, sim session, and now we see our Nano server VM ready on Nano, ready to go. So that's our first VM running Nano on top of Nano, Nano, Nano.
Hey, do you mind if I show them a trick?
Yeah, sure.
How are we doing on time?
We're 62, so...
No, we're not. Come to my PowerShell Unplugged, and I'll show you a trick to how to make that even easier. So, Dan, that was great, but that was Nano on Nano. Does Nano require Nano VMs?
No. So we can run full server if you want. I mean, it's got the GUI stack in there, but if you want, I can try and show a demo of how about Nano running full server.
Sure.
Server 2012 R2 on Nano server.
Yeah.
All right, so let's try that. And this time, so we already showed the commandlets. This time I'm going to use the GUI tools, since we got GUIs involved here. So this is Hyper-V Manager. I'm going to just connect straight to my Nano server here. See, it's coming up. There's our Nano server VM that we created. And I can go through the GUI. If you like the GUIs, it's okay.
It's remote.
We're running it on the client.
As long as it's remote.
Connect our networking if we want. I got a VHD here that's ready to go with server 2012.
How's it over WAN links? I don't think we've changed anything here,
Yeah, that's not changed.
We haven't changed anything.
Yeah, this one is, yeah.
This is using DCOM, yep.
It's the code. So there you go. That's working. And then let's start it up.
I see that? Pretty fast.
Yeah, not bad. Let's see what it's doing. See if this works. Does it like to recreate a VHD? A VM from an existing VHD? Should work.
Yeah?
Might take a minute. It's getting some devices ready.
Great.
And there you go. Server 2012, full, running on top of Nano, on top of Hyper-V, on top of Nano.
So let's see if we got that right. So we've got a client here. We've been using the client GUI to connect to a remote Nano server hypervisor. On that, we ran full server.
Yep.
And we connected.
Yep.
By VM
inside
Connect.
a VM. Yep.
Cool. So the real point you've been seeing is that headless does not mean GUI-less. Now, nobody's a bigger fan of command line scripting than myself, but we also support GUIs. We love GUIs. They're just remote, not local. Okay, so now let's talk about the setup and event collection. So one of the challenges you have is, okay, so I've got this headless thing. What if something goes wrong? What if something goes wrong during the setup? What if something goes wrong during the boot sequence? And so what we've done, and by the way, again, we do this for Nano Server, but then it extends to everything, all the SKUs, is we set up this boot eventing collection. So what happens is during the boot, debug and various progress records are generated as events that can then be forwarded. Again, what you're seeing is from physical or virtual machines. These get created into ETW events that can then be sent off box to an ETW collector that then can be analyzed. Okay, so this is what a collector looks like. So on a collector, you configure it and you say, where do you want to listen? How big do you want the log files to be, etc. And then this is all going over KDNet. Okay, so that's going over Ethernet. And you have to give the MAC address or IP address of where you're going to accept events from, and then it creates a log for each one of those machines. Each one of those machines.
Come over.
Let me get this working. Give me my keyboard back.
All right.
Can you shut that down or something?
Oh, there it goes.
Good God. Okay, so and this is as part of the BCD configuration. Here's where you say, do you want to forward events, and then the settings for where they should go. So the port, the IP address, etc. And let's see if we can get this showing.
All right. So let's see.
Here,
Minimize this thing.
escape.
Ah, thank you. So this guy.
You really wouldn't believe the setup we have here.
Yeah, we've got a lot. This one requires even more, so yeah. I'm going to show you how this one goes.
Can we get the audio, please?
Our collector is running on a VM that's hosted on a 2012 R2 Hyper-V host, and the target machine has had its disk.sys file renamed, and it's sitting in a VM running on a Windows Server vNext Hyper-V host. So the first thing, let's take a look at the configuration of the collector. We use XML to define the configuration, and there's a few key things to look at in this configuration file. The first is the collector port. This is the port that the collector is going to listen on. The next section is defining the location and size and quantity of the ETL files that are going to be kept for each of the target machines. The next is the target section, and this section is repeated for each target. You define the IPv4 IP address, or in this case, the MAC address of the target machine. You also specify the key. This key is used between the collector and this target to ensure the secure communication between the two. And there's also the computer value. This value is used in the folder configuration as well as the file name. The ETL files, by default, are stored under the ETL folder. In this folder, a folder will be created with the target name, and within it, the ETL files will be created. So let's go back to our Hyper-V host and start our VM. You'll notice that the ETL file is now created, indicating that the communication between the collector and the target machine is successful. And we've hit our boot issue. So let's go ahead and turn this one off and go back to our collector and take a look at what's going on. I like to use Microsoft Message Analyzer, which is available via the Microsoft Download Center. It's a free tool, does a very good job of correlating data and analyzing data, looking for problems. So let's go ahead and start a new session, and we're going to load our ETL file. You'll notice here that we've got 17 messages that were collected between when the system came up and when it hit its boot failure. Now, under normal circumstances, this file can have thousands and thousands of messages in it. And to be able to really hone in on the ones that are important, I've actually created a filter that looks specifically for the debug followed by a fatal system error. And we're going to apply this, and this will clear out all the noise down to just a single file, or single message or messages that are matching that filter. So in this case, we can see exactly what was posted to the screen, which was a 7B, which is an inaccessible boot device. So now let's go back to our Hyper-V host and edit the file and show you what the configuration file looks like on the target machine. During this whole entire process, as it's booting up, the collector is still collecting events. So while we're not actively looking at the file, you'll notice that it's continuing to increase in size, indicating that it's collecting the events from your target machine. And now we can log in and take a look. The settings on the client are stored under BCD. And you notice here we leverage the event flag to indicate that we want those messages sent to our collector. And under the event settings itself, you'll notice this is the key that was specified in our configuration file. This is the IP address of the collector itself. And this is the port that we've told the collector to listen on. Thank you.
All right.
There you go. I'm back. All right. So that was this PEC. Feel free to, we're going to post that video again on Channel 9, so you'll be able to go back and review. It's kind of quick. But now we want to move and talk about remotely managing Nano using DSC. So we have the DSC Local Configuration Manager, the LCM, that's now ported to Nano. And we have a handful of the resources available. So you'll be able to use some of that. What works today, we've got the DSC V1 features, so things like partial config, the pull client, configuration, compilation, all that stuff works. What doesn't work yet is a lot of the stuff we're still currently working on in V5, which is the DSC V2 stuff. So cross-machine config, run as. Some of those things aren't quite ready yet. And of course, any resources that depend on stuff that isn't in Nano, those aren't going to be available yet until we start to bring those in. And we'll have a demo. We have a demo of DSC that we'll also be posting on the Channel 9.
Okay, let's switch gears so he can. And which one are you? BJ1. All right. So now we're going to switch gears a little. This is superstar Andrew Mason. Andrew is one of the primary drivers behind Nano Server. So all this great work, you know, he's the guy, big team behind him, but Andrew's been working on this for about 10 years. Anyway, so now what we're going to do is we're going to show you, we've shown you how a number of your existing tools work against Nano Server. Okay? Now, somebody had asked, hey, does that thing work across wide area networks? Because, boy, there's some issues around wide area networks. You'll see what we're doing now is we're modifying and we're switching gears and we're going to be moving a lot of these tools. A lot of these tools don't work well over wide area networks. And there are some tools that don't work remotely. So three things. One is we're making a migration to web-based tools, in particular Azure portal-based tools, or tools put into the Azure portal framework that you can run in Azure or on premises. Number two, a bunch of the tools that don't have user interfaces, remote user interfaces, we are giving remote user interfaces to, web-based interfaces to. And three, a number of the tools that didn't work very well remotely, we are reworking with new instrumentation to be able to work better in this environment. And with that, Andrew.
Yes. So thank you, Jeffrey. So up here I have my Nano server cluster that I used in the demos yesterday. And on Nano GB02, I also have a full server VM running with all the tools running in it. So I'm actually using terminal services to connect up to the virtual machine and run a browser in that. And then I'm connected up to the actual host machine, which is running Nano server. And you can see here, this is a replacement for control panel. One of the things that you often have to terminal server or RDP into a server core machine for, and run sconfig to do network configuration and things. You can see up at the top it's showing me sort of the essential information about the machine, the computer name, the IP address, what edition it's running, and things like that. And if I click all settings, I get this pop-out that then lets me drill into various configuration settings. So in here you can see I get the branding string, again showing Tuva, like Dan pointed out earlier. I can go under the computer options here, and I can change the computer name, I can join workgroup or domain, I can create domain users, I can drill into my network so I can see my network adapters. This machine only has one in it, but I can expand that out. And in there, I can then change my network configuration. So I'm using DHCP, I could set it to static and enter my static IP address in here. Updates and refresh settings are coming. I have a variety of performance details I can drill into as well. So this is sort of my remote version of Task Manager. So I can see my CPU performance. I can then, again, also drill into my network performance and see my adapters and addresses. Going a little fast because we're running short on time. You can look at your memory here. You can also look at your disk performance counters, and you can drill into your actual disks and get more details on them. And then down here at the bottom, I also have a bunch of replacements for tools that, like Jeffrey was saying, either don't work very well remotely, maybe they have slow performance. So we're starting to build out that set of tools, and we're going to keep adding to it. So in here, I actually have a process list. I can right-click on a process and do my common tasks of ending or create a process dump. I can also run process from here. I can do the same thing with services. So I can go in here and I can stop service, start service, pause, resume. Much like Dan showed you could use with the PowerShell commandlets. I also have a remote GUI version of Registry Editor. And here I can drill into specific registry keys. And you'll notice at the top, each of these boxes has a search on it. So I can filter within the view I'm in. So as I start drilling down, I can do a search, and it narrows it down. I can do roles and features. And this right now is just a view of what's installed. And then PowerShell, since everybody's very excited about PowerShell in the room, this is pretty
Everyone's
slick.
excited about PowerShell.
This gives me a remote PS session into that machine from the browser.
And why don't you end on this point?
And then
You get show command.
you get show command. It filters it down for me. And then it shows me the parameters that are applicable on that command.
Is that crazy? Show command in a web browser. Anyway, there's a ton more to see.
So you can fill in the commands there, and there is a ton more to see. And one thing I did want to point out is the great thing about these is these are all built on WMI and PowerShell. So everything that these GUIs are doing, you can do via scripting and automation or write your own GUIs on top of.
It's as though there was this thing called an architecture. It's amazing.
And so this, let me show Device Manager really quick.
Yeah.
So Device Manager is actually layered on top of the PNP device that Dan showed earlier. So you have remote.
It's layered on the PNP device.
Yes, it is.
Great.
Yeah.
Awesome. Okay, we're almost done. Okay, so we're going to recap. Nano server management. Nano server management. Isn't it beautiful? Okay, DevOps mindset. You don't want to be treating your servers like pets. You want to treat them like cattle, right? So stop naming your servers Fluffy and Muffins. Start giving them numbers. Next. Oh, you horrible thing. Okay, next. We don't want to ever sit in front of a server. This is a bad thing. Crash cart equals bad. We want to do remote management. We like remote graphical and web-based tools. Yay, yay, yay. And we love remote management and automation via PowerShell and WMI. Now, let's be clear here. We're leading the way. In order to be successful, a lot of your vendors are going to need to get with the program. You need to whack them on the head. Next time someone tries to sell you something and that requires a local admin GUI, give them a whack on the head. Say, hey, I thought you were a server product, because server products don't do that. Get with the program, okay? Call to action. So use the new and existing tools to manage Nano Server directly. Try it out. Let us know. You have bits today. It is early days. Okay, so let me be clear. It's early days. We're not shipping this thing till next year. But there's an amazing amount of stuff there, and we're moving rapidly. We would like to understand your experiences, your pain. Your pain will then drive our feature development. So send us feedback at that space.
So the web GUI is not available in TP2.
And the web GUI is not available in TP2. So what the large print giveth, the small print taketh away. That will be coming. And thank you very much. I hope you had a great Ignite.